As in the previous video, we had started our third chapter, that is motion in a straight line, and in that top video, we had discussed the introduction part of the motion, and there we had discussed about the various branches of mechanics, what are the various branches, and what are the role of the various branches. In very brief, we had discussed about what is motion, what is rest, what is the importance of frame of reference. All things we had discussed in the previous video. Now, today we are going to discuss about rest. What is rest? And rest means if the position of the body does not change with respect to its surrounding with the passage of time. If position of the body is not changing with respect to time, as well as surroundings, then such type of body is called as rest. Then such bodies are said to be in rest. Such type of bodies are said to be in rest. Example: a book lying on the table, a person sitting on chair, a book lying on table. So in the previous video we had discussed about the position of the body not changing with respect to time. I had made it clear, as well as its surroundings. What is the meaning of surroundings? Suppose you are sitting in a train and a tree is in the surrounding of you. You are sitting in a train, you are in the train and a tree is outside. You are looking on a tree. This is tree. You are looking on a tree which is surrounding you, and as the time passes, with the passage of time, what you are observing with the passage of time, you are observing that the tree is at its own position. The tree, wherever in the starting you are seeing the tree, the same position of the tree is after the passage of the time also. And so you say that the train is at rest at that time. The train is at rest at that time, because with the passage of the time, the tree is not changing its position, or with respect to the tree is not changing its position. And so you are saying that the train is at rest. But if it happens that with respect to the tree is changing its position, means sometime 1 minute before you are seeing the tree parallel to you, and after that you are seeing the tree is behind you, means that with respect to the surrounding, the train is changing the tree changing its position with respect to time surrounding. The train is changing its position, or you can say that the tree is changing its position with the passage of the time. So you can say that the train is in motion. Means with respect to the surrounding or with respect to the time, if the body is changing its position, then you are you used to say that the you are in rest or in motion with respect to the time or surrounding. Now similarly we can describe the part motion also. Similarly we can describe the part motion also, just opposite to this motion, just opposite to this motion. If position of the body is if position of the body is changing, position of the body is changing with respect to time as well as surrounding, with respect to time as well as surrounding, then such bodies are said to be in motion. Such type of body is said to be in motion. The such type of body is said to be in motion. Motion is change in position of object with time. It is common to everything in the universe. In the universe, each and everything is in motion. In our daily life, train moving on the train moving on the railway track, man walking. Example of this: train moving on railway track, train moving on railway track, man is walking, man is walking. Crawling of insect, crawling of insect, etc. But here also I am saying that in both the cases are not discussed about the frame of reference, because rest and motion are not, again I am saying that rest and motion are not absolute terms. The rest and motion are not absolute terms. Again I am writing rest and motion are not absolute terms. They are not absolute terms, but they are relative. But they are relative. Relative means to say that absolute means not perfectly rest or not perfectly motion. You cannot describe any object that an object is at complete rest. Means if you are observing that object, then you can say that the body is rest, because with respect to you the body is not changing its position with the passage of time along with the surrounding. But if the observer is somewhere else and after that he is observing the object, then with respect to that observer, it might be possible that the body is in motion with passage of time or with respect to surrounding. Similarly, certain object you are observing, and as you are the observer, with the passage of time or with respect to the surrounding, the object is in motion for you, but for another observer or for the other observer the same object might be in rest also. So rest and motion are not absolute terms, but they are relative terms, they are comparable terms. One observer can be at rest, but the same object can be in motion when observed by the other observer. Suppose I am taking an example for that. To clear this concept, I am taking an example. Suppose you are in your house Suppose you are sitting in your house. This is your house and you are sitting in your house. Now I am standing here. I am standing here. You are in house, I am standing here, and I am observing you that as the time passes, as my clocks reads the time, it goes on, and with respect to the surrounding also, your position is not changing. Your position is not changing. Your position is not changing. Then I quote that, then I say that you are in rest. But suppose I had shifted myself at moon. Suppose this is moon, and I had shifted myself here. On the moon's surface I am shifted myself, and from there I am observing you. Since moon is moving, so I will observe you that you also, moon is moving with respect to earth, so I observe you that you are also moving. So for the same observer, one time you are at rest, and another time you are in motion. Now another example, take another example. Suppose there is a train. And you are sitting in the train. This is train, and you are sitting in the train. An observer is outside the train. This is observer, who is standing outside the train. Since the observer is standing outside the train, so with respect to time, with the passage of time, and with respect to the surrounding, the train is changing its position. At one time it is here, after certain time the train becomes here. Means the train is changing its position with respect to time as well as with the surrounding. So you can say that the train is in motion. But if you had shifted yourself inside the train, and now you are observing, this is object, and this is observer. And if the observer is shifted himself inside the train, and after that he is seeing the object, he quotes that, he sees that the position of the object, with the passage of the time, the position of the object is at the same place where he is before. So he can say that the same object at one time, for the same observer, the same object is in motion, and another time the same object is at rest when the observer shifted its position. So we can say that no object is at absolute rest or at absolute motion. And this is the concept of frame of reference also. Frame of reference, again, when I will discuss about the frame of reference, when I will going to define frame of reference, then same examples I will take to clear you the concept of frame of reference. So now this is about the relative and the concept of absolute and relative terms about rest and motion. Now we will discuss about types of motion. What are the different types of motion? Types of motion. Types of motion. Types of motion. Different types of motion had been classified on the basis of two things. The first classification is based on the first classification is based on the path followed by the motion. Nature of path followed by the object. What is the nature of path followed by the object? On that basis, we will discuss the types of motion. So first one is on the basis of path followed by the object. On the basis of path followed by the object, the classification is first is rectilinear motion. Rectilinear motion. Rectilinear motion. Motion in which a point object moves along a straight line. Moves along a straight line. Here I had mentioned about the point object. Motion in which a point object moves. I will define point object and extended object just after this discussion. Motion in which a point object or a particle, you can say that a particle moves along a straight line. Such type of motion is called rectilinear motion. Example, there is a quite difference between rectilinear motion and translatory motion. There is another term, translatory motion. Both are the motion in a straight line. But in rectilinear motion, we consider the object as point object. We used to consider the object as point object. But in case of translatory motion, the object cannot be considered as point object because whole particle of the object is moving on the straight line. Suppose this is a point object, so we had considered a point object and it is moving in a straight line, then it is rectilinear motion. But suppose we are not in the position to consider this object. We are not in position to consider this object as point object. So various points in this object are expected to move in a straight line. So such motion is called as translatory motion. Example of translatory motion is motion of an object on an inclined plane. Sliding body on an inclined plane. Example, any point object, you can call it as ant is moving on the edge of the wall. You can say that it is rectilinear motion or motion in a straight line. Point object moving in a straight line. This is rectilinear. This is example of a rectilinear motion. And the second one is ball is sliding on an inclined plane. The ball is sliding on an inclined plane. Each component of the ball is sliding or moving in a straight line. Each and every part of the ball is moving in a straight line. Sliding, it is sliding just like that. Though this is the translatory motion. This is translatory. This is translatory motion. So a very little difference between rectilinear motion and translatory motion. Now the second one is circular motion. Second one is circular motion. Second type of motion is circular motion. What is circular motion? Obviously, as it is clear from the name, when the path traversed by the object is circular. When path traversed by the object is circular. When the path traversed by the object is circular. Example: a whole string moves in a circle. Word string moves in a circle, or you can say that circular loop. In a circular loop means, suppose this is the center, you have tied a string and that stone is moving in a circular loop. So whatever the path followed by this stone, this is a circular path. The third one is oscillatory motion. It is clear to all had studied, these are the basic things. Oscillatory motion, simple pendulum motion, to and fro motion, back and forth motion. The motion in which particle moves to and fro about the given point. Oscillatory motion in which object moves to and fro about a given position. Example is simple pendulum. This is bob and thread. You had already studied these things. This type of motion, this motion, to and fro motion, and this is the motion of the simple pendulum. And this motion, extreme position, mean position, extreme position, mean position, just like that. This motion is called as oscillatory motion. Now, on the basis of coordinates required to define the motion. On the basis of coordinates required to define the motion. coordinate required, on the basis of coordinates required to define motion. All of you had studied about the coordinate system. In class 9th in mathematics, you had studied about the coordinate system, and in physics till now we had studied only about three coordinates. Three coordinates are any object. For specifying the position of any object, we used to select only three coordinates. Till now you had studied about the two coordinates, that is coordinate axis, x-axis, y-axis. These are the two coordinates, and that is the z-axis. And all the three axes are mutually perpendicular to each other. To understand this, because this is the two-dimensional board, so the third dimension is not appropriately drawn on over here. So try to visualize this thing. I am saying that suppose the corner of the wall, of your room. So one edge is x axis, other edge is y axis, and the top edge is z axis, x axis, y axis, and z axis. So on the basis of the change of an axis of the object, we can classify, on the basis of coordinate system, we can classify the motion as, first is one-dimensional motion, then two-dimensional motion, and three-dimensional. First is one-dimensional motion. One-dimensional motion. What is the meaning of one-dimensional motion? If any one of the coordinate is changing for specifying the motion of the object. Suppose I am saying that this is two dimensions, or x-axis, y-axis, x-axis, y-axis, and z-axis. Okay, this is the origin. And any object is moving only along this axis, means at any time t, the position of the object can be specified as a00, means at any time t, the position is a00, and after time t dash, the position become b00, means with the passage of time, only one coordinate, since the object is moving only on this coordinate, then only one axis is changing, so the motion is called as one-dimensional motion. Suppose an object is here and its coordinate is 0, a0, and after time t it becomes 0, b0, only one axis is changing. Suppose here also in the similar fashion, at any time t, the coordinate is 0, 0, a, and after time t it becomes 0, 0, b, means any of the axis, if on any of the axis the object is changing its position or coordinate is changing with the passage of only one axis is changing with the passage, only one axis is changing with the passage of time, then such type of motion is called as one-dimensional motion. I think all of you got it, so note it down. Motion of an object. Motion of an object is considered as one-dimensional if only one coordinate is needed to specify the position of the object. Position of the object. Only one coordinate is Clear? Now two things will be possible here. Suppose this is origin. Any object is moving in this direction and any object is moving this direction. So in the left side, in the right side of the origin, we consider it as positive, and in the left side we consider it as negative. So, and its example, simple example, a boy moving on straight road. A boy moving on a straight road. A boy moving on a straight road. A boy moving on a straight road, a cycle moving on a straight road, anything you can say that. A rocket moving along upside any axis, that rocket, no other coordinate is changing. So such type of examples are one-dimensional motion. Now two-dimensional motion. Two-dimensional motion. Similarly, you can say that two-dimensional motion means two coordinates are changing. Two coordinates are changing. Suppose an insect is two-dimensional motion. Second is two-dimensional motion means for specifying with the passage of time or specifying the motion of the object, two coordinates are needed to specify the position of the object. Suppose object is here at t is equal to 0 or t is equal to t, the object is a, b, c is 0, z coordinate is not included, and after time t the object becomes at p dash and c, d and 0. So here the position can be specified by two coordinates. Two coordinates are needed to specify the position with the passage of time. With the passage, this is time t and t dash. Such motion is two-dimensional motion, or its example is insect crawling on the wall. Insect is crawling on the wall. Suppose there is a wall and insect is crawling. So to specify the position with respect to time, two coordinates are required here. And three-dimensional motion. Three-dimensional motion are such type of motions in which all the three coordinates are required to specify the position of the object or motion of the object. X, Y, Z. X, Y, Z. And this type of motion is the motion in space. Motion is in space. Suppose here I am taking, since it is two dimensional, so I cannot clarify here. P is equal to A, B and C. All the three coordinates at time t, and P dash, D, E and F. After time t dash, at time t, A, B, C, and after certain time, that is t dash, the coordinates become, all the three coordinates are changing. So such type of motion is motion in space, and all the variation of all the three coordinates are required here to specify the position or motion of the object. The simple example for that is bird moving in a garden. Bird moving in a garden. All the motion which is in a space, which is in a space, you can consider such type of motion as three-dimensional motion. Suppose a mosquito is here inside the room. At time t, when you are observing that mosquito, it has the coordinate A, B and C. To specify the position of that mosquito, we have to specify its x coordinate as A, y coordinate as B and z coordinate as C. When there is the passage of time, the insect reaches the position D and E and F, where the x coordinate can be specified by D, y coordinate is specified by E and z coordinate is specified by F. So with the passage of time, all the three coordinates are changing. So such type of motion is called as three-dimensional. Such type of motion is three-dimensional motion. So I think it is clear to all these things: classification of motion and rest and motion, relative terms, how they are relative terms, all things had been clear to you. Now in next video, tomorrow's video, we will discuss about point object and extended object, and then we will discuss about position, path length and displacement, and in the same context we will discuss about frame of reference. So that's all for today, students. Thank you. Have a nice day. Take care.